Hello everybody, welcome to this webinar. My name is Michael Wiendl, I'm an NC trainer at Heidenheim in Germany, and today I want to show you the new possibilities of our optimized contour milling cycles. These OCM cycles are available on the TNC 640, the first time with the software 10, and you need the option 167 to activate these cycles on the TNC 640. First, a short overview about the content during this webinar. We take a look at the possible applications. Then we watch how the OCM cycles are working. We take a look at the programming. And of course, at last we have an example, at first theoretical at the presentation, and then later on practical with our programming station. So the new OCM optimized contour milling cycles are new SL cycles, so contour milling cycles. So we work with different contour programs. So these are the descriptions of the contour elements. And when we combine they all together, then we get a new contour milling cycle. And the special thing of this new contour milling cycle is the tool path overlap is constantly over the complete milling process. And that's a new possibility, and you see it in the picture with the milling path, and these are automatically calculated directly from the control. So the cycles, we have new cycles, cycle 271, 72, 73, and 74. So we can easily program them on the control. We just need the contours, combine the contours together, and then we can work, for example, with an open frame outside that the tool can go outside to inside without any necessary helical inside movement. And the main thing is that we always take care about the tool path overlap here. And you see the nice calculated milling path here for this example. And that's the big benefit of this new OCM cycles. So the programming, one important parameter is the open boundary parameter. So the Q569 in the line number 6, you see it in the cycle 271, the last parameter, the Q569. Here we have 0 or 1, and there we can say if the boundary should be closed, like this example, a complete closed boundary, or if the boundary should be open. And open is, for example, a workpiece like this. There is just a small part open, and the control or the end mill can use this open part to go inside of the material. Of course, the boundary could be also completely open. That depends on the definition inside of my contour, how I program my contour elements. The most important parameter is the tool path overlap. There we defined the side step of the miller, and this will be constantly checked over the complete process. So, and that's the good thing. The conditions of the process will not change during the OCM machining, because the load to the spindle and to the machine will stay all the time the same, because we always work with the same tool path overlap. And that's the main important thing of the OCM cycles. And the control calculates automatically all the milling paths for the actual tool with the actual radius, and we can easily do a change in the program, and the control automatically calculates the new values. Also interesting for residual material that we can define, we do not need to define the tool what machined before. With the entry -1, the control just takes the radius from the last cycle 272, so from the last roughing cycle, and uses this parameter as an information for the next roughing cycle, just to know how much material is still on the workpiece. And here we have an example. That's a simple triangle with a corner radius of 2 millimeters. And in the first step, we machine it with a diameter 16 miller, just to bring the most material out of the pocket. In the next step, we use a diameter 10 miller. And now you see this miller just takes the corner material here in all 3 corners. And in the last step, we take a diameter 4. And with this, we can finish the complete machining. So we do not need to say to the control that we at first machined with the diameter 16 and the next step with the diameter 10 with the parameter -1. We can, the control just makes this process automatically. Also, finishing is inside, of course, with a good approach and departure movement, that we will not get any marks on the contour after finishing, and that we get a good and clean workpiece here. Let's take a look at our example workpiece, what we want to do later on at the programming station. So this is a workpiece with an island and 2 pockets on the workpiece. So we want to do at first roughing with a diameter 16, then residual material machining with a diameter 10, and finishing at last. At first we need the contours, therefore we are using our CAD Import option and just take our frame, the outside contour, that the control knows where the material starts. The next step is the island in the middle, and the first pocket and the second pocket. So these 4 contours we just take with our CAD import. That's easy because then we do not need to program the contours by ourselves. We just take it out of the step file here directly on the control. These 4 contours we combine in the contour depth function. In this function we can combine up to 9 contours. If the contour depth has not enough contour elements, so if you need more than 9, then we also have the complex contour formal. And that's up to 128 contours what we can combine together. Then we program the cycle 271. These are the contour data for the OCM cycles with the deep and everything. And later on the cycle 272 for roughing. The residual material we take away with the diameter 10. And another cycle 272. And at last we are doing the finishing. So we see here the complete roughing process, so with the diameter 16 and diameter 10 residual material machining, and afterwards the complete finishing process. Let's change to programming station. Here we have a normal TNC 640 programming station, software 10, of course. See here, software 10. Service Pack 2. And I prepared a little example program with the blank form already in it and some structure with some tool calls. And now we start with our programming. So at first we need the contour elements. For this I open the step file. The control automatically opens it in the CAD Import. Here we see now the workpiece. The datum is already in the middle. I could change it if I want with the preset function here, but we can directly start with the contour selection. So I select the contour, I click on the first line, and now the control follows automatically the contour, and I can just click on the last line here, and then I have these 4 elements selected. Save. I define a name, for example, for the frame. Okay. And I delete this contour. And this process I now do with all my elements. So with the island, also here you see everything is selected, and I can just click on the last file, on the last line, and then the complete contour is closed. Store, say island. Okay, delete the contour. Then we take a look at the pocket here. One click. I can also choose it by click the last element in the drop down list on the left side. Just click here, and then I also choose the complete contour here. Save. Pocket 1. And the last one here. Also choose in the list and store, and we say pocket 2. So now we've chosen the 4 contours, and we can close the CAD import and go back to the program. Just activate one time the folder, then we see the contour elements. When I open, for example, the island, here you see all the necessary sentences for the island, and we just easily take it with the CAD import. Otherwise, we had to program all these values by hand, and this is not so easy. And also for the CAD constructor, he has to output a correct drawing with the NC points selected in the drawing, and that's often not so easy. So the easiest way is to do it with the CAD import. So let's come back to our program. So here we start now with our first roughing with the diameter 16. Now I have to say the control which contours I want to use in this milling process. So I go to the special function and contour and point machining and contour depth. This is the contour depth, the simple contour formula. And this formula always starts with the deepest pocket. So the first contour is always a pocket. And I can say select file, and I choose the frame. Okay. Then the second element, I can choose if it's a pocket or an island. So for our example, this is an island. And I can say select file and island. Okay. For the second element, I can make a different depth. So for the island, it's from the coordinate surface to the top position of the island. And if you have a pocket, it's from the coordinate surface to the bottom of the pocket. So for the island, it's the top. For the pocket, it's the ground of the pocket. In our example, all the contours are on the same level, so we do not need the depths here. So we go on to the next parameter. So the next contour element should be a pocket. Select file, pocket 1. Okay. Also no deep, and the last one is also a pocket. Select file, pocket 2. Okay. And end of block. So this is the information for the control, which contours we want to combine together. And now we come to the OCM cycles. So we press the cycle def key, then SL cycles. And on the last floor here, we have the new cycles. The 271 is the contour data for the OCM function. 272 is roughing. 273 finishing floor. 274 finishing side. So we start with 271 and we define our values. We want to do later on a finishing for the side, not for the floor, and all the other parameters we just let inside as they are. Cycle def, SL cycles, last floor, 272, roughing. So we want to do the complete depth in one step, and now the tool path overlap. So, and at this moment, we now can use the OCM cutting data calculator to get the correct tool path overlap, feed rate, and spindle speed for my material. And here you see we have a calculator. In this calculator, we define the limits of the machine, so the maximum spindle speed and the maximum milling feed rate. And we select our tool, what we want to use for this process. And we can select the material, what we want to do. For example, we want to do 1.43. We can here use the stainless steel, can select, and then the control automatically calculates the cutting data here. And when I want to do some changes in the cutting data, I can use the mechanical load and I can use the thermal load. And with these parameters, I can just change the values here. So when I change the mechanical load, then the control reduces the tool path overlap. So then we get more and more material with one cut, and so the mechanical load becomes higher. Or the thermal load, if we make the thermal load higher, then the feed rate goes up. If we reduce it, the feed rate goes down. So that's the possibility to change the calculated parameters of the control. Normally, there is a good starting point to use the normal calculated values here. Then I can say apply. And then the control just brings the tool path overlap, the feed rate milling, and the spindle speed automatically to my OCM cycle. So M99, and let's take a look at the graphic simulation run. And we see here, when we just bring in the tool path, that they are really nice calculated small values. Of course, we have now the 1.43 stainless steel. That's why the tool path overlap is really small here. Of course, when I have aluminum, then the tool path overlap becomes bigger. But we see that the machine or the control is not machining the complete island. It's just a small part of the island. Also, the first pocket could be machined, the second pocket not, because there the diameter 16 miller has no space inside. And that's why the control will ignore this pocket. But this diameter 16 could also do the outside machining here. And this we can just easily activate with the parameter in the OCM contour data 271 when we switch the open boundary to 1. Then the tool is allowed to overlap or to go over the outside frame contour, and then with this behavior we get a new situation, and now the tool can go from outside to inside and can machine the complete island here with the diameter 16 miller. And these milling paths are automatically calculated from the control. So if we do some changes in the cycle and we go back to program run, then we can automatically use the new values directly, and there is not much calculation time, and we do not need to wait to create the complete program before we start the machining process. So in the next step, we need to take a look at the residual material, and there cycle def, SL cycles, and the last floor, cycle 272 again, plunging depth 30 millimeters, OCM cutting data. We select the tool, diameter 10, okay, and we say apply, and the control takes all the values automatically in the cycle, and with M99 we call the cycle again. And so the conditions during the milling process are always constantly, because the control always has the same tool path overlap, and so the process is constantly the same all the time. And we can use the complete cutting length of my milling tool. And now we see the new tool, the diameter 10, and this tool is now milling the complete residual material. Of course, also the second tool will not damage the contour. So when there are elements which are too small for the diameter 10, then I need another miller to make the finish of the contour completely. And here we see in this dark green areas here, there the diameter 10 tool was working, and now the roughing is finished, and we just do the finishing process, cycle def, SL cycles, and 274, just finishing the side, finishing feed rate, F auto, pre-positioning with max, and the rough tool. Here we can say -1, then the control takes the last radius of the cycle 272, or when I want to define it by myself, then I can say the last tool was the diameter 10 rough tool here. And M99 to call the cycle. And now we see the roughing, and after the roughing, the residual material. So always imagine we are machining stainless steel. That's why the tool pass overlap takes a little bit more time, because the tool pass overlap is smaller, and the diameter 10 we have here now 30 millimeters deep, and with a small tool pass overlap we machine through the complete workpiece. Yeah, finishing also done. Then we have a good surface quality, and now we can see our workpiece completely programmed directly on the machine, together with the CAD import to easily transfer the contour data to our program. And that's the good possibility of the TNC 640 with the OCM cycles. Yeah, thank you for your attention during this webinar. I hope I could show you some new possibilities with the OCM cycles. So if you are interested, just contact your machine tool builder. He can activate this option when you have the TNC 640 with the software 10 on your machine. If you have any questions regarding this webinar or also other topics, just phone us with the telephone number or write us an email. So thank you. Hope to see you the next time at the next webinar. Bye bye.